Looking at our execution plan here, this top branch of the plan up here is looking at ref.firstname. I'm joining and saying, okay, I want to decode the first name, and that's what the top block of the plan up there is. I am getting parallelism. We can see from all our double yellow lines, but look at this bottom branch. I keep going to the right. I mean, wow. So we are doing, I haven't given it any non-clustered indexes. We're doing a clustered scan on our clustered primary key of first name by year state. And then we're doing a big old sort, and that's leading into segment operators and a window spool operator. I have 4 cores. We are using all our cores, right? So our sort is, it thinks this is estimated cost. Cost is always an estimate, even though this is an actual plan. It thinks that sort's going to be really expensive. And then so segment, what are we doing in here? Let's look at some properties. So for our sort, it thought this was going to be 59% of the cost of the plan. But let's look at our actual time statistics. By the time that this finished, this is in row mode, so our actual elapsed time here is cumulative for this operator and its child operator. So this sort and the clustered index scan and everything, our elapsed time is at 5.6 seconds. Our total elapsed time for this whole query is more than 20 seconds. Our total elapsed time for this query was 33 seconds. So only a small fraction of this was on the sort. What were we sorting by? If we expand the order by down here, I'm in the order by for my sort, I'm sorting by my partition by stuff, my first name ID, my state code, my gender, and then I'm ordering in my window function by report year. So all of the stuff in my over clause where I'm partitioning by first name ID, state code, and gender, and then ordering by report year is what it's having to sort in here. And this makes sense. I want to see, for each row, I need to add up in a group for that first name, state code, and gender. Okay, what's my running total, for that year? So I've got to sort by those things. It then feeds that into a segment operator. The segment operator, what's this one doing? Look, there's a group by on this segment operator. We are grouping by first name, ID, state code, and gender. I'm doing a running total for this year and then running total, right? I want this year and all the years prior, but I need to group by. So I've sorted by all of these things plus report year. And now in my first segment, I'm starting to figure out my windows. What's our actual time now? We are once again in row mode, and we can see that at the top. Let me zoom out here and prove we are in actual execution mode is row mode. So when we're in row mode, our actual elapsed time is it and its children. So it includes that sort. So now we're up to 6 seconds. The next segment operator, okay, we're up to 6.5 seconds. Everything is in row mode in this plan. And now when I look at what I'm grouping by here, and it's like the battle of the column widths. Now, this one is saying, okay, I'm working more on my running total. I'm bringing report year back into this. And we've already sorted by that to make it easy. And now, after that, we go to our window spool. Okay, and what does window spool does? This is expanding that set of rows. So we ordered everything. We've been segmenting the data. And now we're actually using our window spool. What is taking up all our time? Well, wow, okay, this is it and its children. Its child had 6.5 seconds. Now, by the time we get done with this window spool, 24 seconds. So the work of sorting is a lot, but like actually working through the window spool and expanding all the rows and figuring everything out, even though this thing is parallel, right? We are using 75, almost 76 seconds of actual CPU time because we're parallel, and we get done with it in about 24 seconds. And we're still pushing, as we finish different windows, it is able to push things into the stream aggregate, but it takes a long time to finish up that window function work. So maybe By creating a non-clustered index, maybe we can get rid of that sort operator and make the work of that segment, the segment operators easily. SQL Server thought that sort operator is going to be a lot of work. It looks like that estimated cost for it's a bit high compared to everything else for me, but maybe we can just make it go away by pre-sorting the data in a non-clustered row store index. When you're designing these, Itzik Ben-Gan wrote a great article about this. And essentially what we're going to do is, you know how we saw those columns that it's grouping by? We're just going to index based on that group by. But Itzik, in his article, he said, okay, there's an acronym you can use for remembering this, and I think acronyms do make things easy. So POC, we're going to index for the partitioning columns. We're going to put those in the key of our index. We're going to index for the ordering columns. We're going to put those in the key for our non-clustered index, and then we're going to index for anything else we need to cover the window function. So let's look back up at our window function here in our top pane. Expand out our code and our procedure. Here is partition by. These columns, first name, ID, state, code, gender, suitable for the key. Then we've got our order by column, report year. Let's put that in the key. Name count, right? Now we need to cover other things in the index. We're summing up name count for our running total. We also need that in the index, but we don't need to order by it. So we can put that as an included column in our index. So that's what we mean by partition by, order by, covering. So we're going to create an index for first name, ID, state, code, and gender as our key columns, report year, tack it on to the end of that key for our order by, and then we're going to cover name count as our included column. This row store index isn't huge. It just takes a couple seconds to create. And what we're hoping to do is to pre-sort the data to make this all a lot faster. Now, how fast is this going to make it? I'm going to turn this on, run this with actual plans. That what we saw when we were looking at the query time stats, and this took 33 seconds. It often takes about 26 seconds on my machine. The 33 was a little bit slow. 26, 27 seconds is normal. When we were looking at the elapsed time in the execution plan properties, by the time we were at the sort, we were only 6.5 seconds in. So if the index, if all it does for us is eliminate that sort, sure enough, now we're at 29 seconds. So we're a little bit faster, but this is not like a massively fast query at this point. Looking at our plan, I do have a little warning here. Let's look at what the warning is. Got a little warning on my select operator there. And sometimes with the properties pane, you have to click around for it actually to get the property of, we want the property of the select operator up there. It's actually showing us what we want now. And if I go down to warnings here, it'll give me details if I pop up. And it's just saying, I allocated more memory to do things like in memory, like sort all that data. I didn't use much of it. So it's not that if we allocated too little memory, I might be like, oh, maybe that slowed us down. Nothing else is running on my test instance. I didn't have to wait to get my memory grant was excessive. Not arguing that, but I didn't have to wait to get it because it's not like I had to compete for that memory grant with a super active server. So not super concerned about the memory grant being what made me slow. Looking at my plan, let's go all the way to the right here. There's a lot of windowing function in there. Now we did use our index. We've got our non-clustered index in play, and it is totally fair that it had to scan it. We want to do a running total for every single row in here and figure out, okay, which rows have passed the threshold we're passing in for a given first name, ID, gender, and state code, and what year did it happen in. So we've got to look at every single row. We do not have a sort operator before we go into our windowing fun, right? We go straight from a parallelism operator into our window function, fun with drawing straight lines here, and our window spool. When we are on this segment operator, let's look at our query time stats, our actual time statistics at the point of the segment operator, we're only at, It's 4.4 seconds before this operator finishes. Looking at the window spool operator, sure enough, it's taking a long time to complete this window spooling. So that hasn't changed. We did remove, by creating this index, we did improve something. We got rid of the sort in here that had to happen before things got fed into the window spool, but the window spool operator is still slow. Well, what can we do to speed this up?